Hello viewers, welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be solving this beautiful integral problem. It says integral from 0 to 1 log of x over 1 plus x dx. So if you are new to this channel, don't forget to subscribe, like, comment and also share. Alright guys, so now let's dive into the solution. If you want to solve this kind of beautiful integral, here's the first thing you are going to do. The first thing you are going to do now is to write 1 over 1 plus x in form of what? Sum. Alright, so 1 over 1 plus x is equal to sum of m from 0 to infinity, okay, of minus 1 raised to the power of m of x raised to the power of m. Are we together? So that is integral from 0, that is 1 over 1 plus x. So it is written as sum of m from 0 to infinity of minus 1 raised to the power of m of x raised to the power of m. Take note of that. So we can now rewrite these our integral as follows. So if we write this integral, so we have integral from 0 to 1 of log x. So instead of me writing over 1 plus x, so I'm going to write sum of m from 0 to infinity of minus 1 raised to the power of m of x raised to the power of m dx. Are we together now? Now next thing we are going to do now is to swap the sum. Right, so if you swap the sum, that is, you are going to bring the sum outside of the integral. So we're going to have sum of m from 0 to infinity of minus 1 raised to the power of m, so of integral from 0 to 1 of log x of x raised to the power of m dx. So which could also be written as sum of m from 0 to infinity of minus 1 raised to the power of m of integral from 0 to 1 of x raised to the power of m multiplied by log of x dx. Now next thing we are going to do now is to make a beautiful substitution. Now what substitution are we making? So we can say that, we can say let log of x be equal to minus lambda. And now don't forget, this log of x we are using here is the natural log of x, that is the basis x e. You understand? The basis e. So what we're gonna do now is to rewrite this, the basis e, so you raise both to what? To the power of e. So if we do that, so we're gonna have x is equal to exponential negative lambda. Then we are going to differentiate this with respect to x and then with respect to lambda. So we're going to have dx is equal to negative e raised to the power of negative lambda d lambda. Yeah, that's actually nice and beautiful. So now you write this integral. So we write this integral. So we have summation of m from 0 to infinity of minus 1 to the power of m. Then now the limits, if you substitute x to be 1, we have log 1, which is 0. And then if we substitute x to be 0, we have log 0, which is infinity. Then we have the integral now from infinity to 0. Then x is now e raised to the power of negative lambda. Then raised to the power of this m, so we have negative lambda m. Then log x, which is now negative lambda, right? Then dx, which is now negative e raised to the power of negative lambda, okay, d lambda. Yeah, this is actually nice and beautiful. Now moving on, guys. So I can bring out this negative sign, I can bring it out. So if I bring it out, I'm going to have minus sum of m from 0 to infinity of minus 1 to the power of m. Okay, now this limit, you are going to switch it. Alright, so if you switch it rather, so this negative sign, what we eradicate. So we're going to have 0 to infinity, okay, so of e raised to the power of negative lambda m, then multiply by e raised to the power of negative lambda, then multiply by lambda d lambda. So we can apply the law of indices right here. So we apply the law of indices, so you are going to add what? The exponent. So we have negative sum of m from 0 to infinity of minus 1 to the power of m of integral from 0 to infinity e raised to the power of, now this is negative lambda, this is negative lambda. So we can actually factor out negative lambda. Then we have negative lambda into bracket m plus 1, then multiply by lambda d lambda. Now the essence of us making the substitution to look like this is that I want to rewrite this our integral, in form of gamma function. So then how can we do that? Now we're gonna make use of another substitution. So we're going to say, let, lambda n plus 1, let lambda n plus 1 be equal to any variable you want to use. So let's make use of j. Alright, so if you make use of j, so then you make lambda the subject of the formula. So we have lambda is equal to j over n plus 1. Then you differentiate. So the lambda will be equal to the j over m plus 1. This is beautiful. Now, we can now rewrite this integral. We have minus sum of m from 0 to infinity of minus 1 raised to the power of m, then of integral from 0 to infinity. The limit is not changing, because if you put lambda to be infinity, that will still be infinity. If you put lambda to be 0, that will still be 0. So we have exponential negative j. Say lambda n plus 1 is now j. The lambda is now j over m plus 1, and the lambda is now the j over m plus 1. Yeah, that is cool. So n plus 1 multiplied by n plus 1 will give us n plus 1 squared. So this becomes a negative sum of m from 0 to infinity of minus 1 raised to the power of m. So we can bring out this. So we can bring out 1 over m plus 1 to the second power. Since this and this multiply together, we have n plus 1 to the second power. Then multiply by integral from 0 to infinity, e raised to the power of negative j multiplied by j dj. Now, let me recall the gamma function. So gamma of 0 to infinity of e raised to the power of negative j, okay, of j raised to the power of n. All right. So, n plus 1. This will give us gamma of n. Take note of that. So that will give us gamma of n. Now, in this case, we can rewrite this, our integral, as follows. Sorry, n minus 1. I'm very sorry for that. N minus 1. And that's going to give us gamma of n. So we can now write this my integral, which is integral from 0 to infinity, e raised to the power of negative j of j dj. So I can say this is equal to integral from 0 to infinity, e raised to the power of negative j multiplied by j raised to the power of 1 plus 1 minus 1. Because 1 plus 1 is 2 and 2 minus 1 is still what? Is still 1. So we can say this is equal to what? Gamma of 1 plus 1, which is 2. And then remember that gamma of n is equal to n minus 1 factorial. So definitely gamma of 2 will be equal to 2 minus 1 factorial. So which is 1 factorial. And 1 factorial is what? 1. So that shows that this integral right here is, everything here is 1. That's beautiful. That's beautiful. So now we can write this as sum, a negative sum of m from 0 to infinity of minus 1 raised to the power of m, then multiply by 1 over m plus 1 to the second power. So next thing we are going to do now is to evaluate this sum. So I can switch the limits, or this m. Okay, so if I switch it, I can say let m be equal to n plus 1. So if m is equal to n plus 1, so that is, let n plus 1 be equal to n. That is n plus 1. I'm going to replace it by n. Do you understand what I'm saying now? And then remember that m is equal to 0. So we're going to have 0 plus 1 is equal to n. So we can now have n is equal to 1. So we've shifted the sum. So we've shifted the sum. So we're going to have negative sum of, so instead of us writing m now, we're going to write n, and then n will be starting from 1 to infinity. Okay, then negative, so instead of us writing m, you write what? If n plus 1 is equal to n, so this means m is equal to n minus 1. So we have raised to the power of n minus 1, then everything over, don't forget n plus 1 is now n, we have n to the second power. Then remember that minus 1 raised to the power of n minus 1 can be written as minus 1 raised to the power of n multiplied by minus 1 raised to the power of minus 1. So which is equal to what? Minus 1 raised to the power of minus 1 is minus 1. So minus 1 multiplied by minus 1 raised to the power of n will give us minus 1 raised to the power of n. Then you have to bring out this negative sign. So this is actually nice and beautiful. So now let's continue. So this will now be equal to, so we have negative sum of n from 1 to infinity, then of everything into bracket. Don't forget minus into bracket minus 1 raised to the power of n, then over n to the second power. Now negative times negative will give us positive. Good. So now we are going to have sum of m n from 1 to infinity of minus 1 raised to the power of n over n to the second power. Now recall that if we have sum of n from 1 to infinity of minus 1 raised to the power of n over n raised to the power of s, this is equal to the dirichilet eta function of s. And then where the dirichilet eta function of x is also equal to negative 2 raised to the power of negative s, into bracket 2 raised to the power of s minus 2, then multiply by sum of s. But in this case, the value of s is equal to 2, so just put 2 there. So we're going to have negative 2 into brackets, negative 2 raised to the power of negative 2, then into bracket 2 raised to the power of 2 minus 2, then multiply by zeta function of 2. So this will be negative 1 over 4, then into bracket 4 minus 2, and don't forget zeta of 2 is what? Pi square over 6. Okay, so zeta of 2 is pi square over 6. Then we're going to have negative 1 over 4, then into bracket 2 multiplied by pi square over 6. So 2 into 1, 2 in 4, that is 2. So we have negative pi square over what? 2 times 6 will give us 12. So we have our answer as negative pi square over 12. Alright, so that's the answer to the beautiful problem. Okay guys, thanks for watching. If you like this kind of video, please don't forget to subscribe, like, comment, and also share. See you next time. Goodbye.